Okay, now that we have the results of the poll, let's see what actually happens.
Question. Will the ruler fly away? Will the newspaper be torn? Observe what happens.
Ooh. One more time.
Observe what happens.
How did that happen? It's a newspaper. I know how strong a newspaper is. I know how strong a ruler is. So what happened? Well, you might have guessed this already, but the answer is air pressure. I told you, and you may not have believed me, but I told you there's a whole kilogram of air pressure on every cubic centimeter. Excuse me, every square centimeter. So if that newspaper is about 30 centimeters times 60 centimeters, it's about 1,800 of these little square centimeters on that newspaper. So there's 18 pounds of air pressure pushing down on that newspaper. That's more than enough to hold down the ruler and make it break when she hits it. So if air pressure is so strong, why don't we normally feel it? And why doesn't it crush us? It crushed the barrel, it crushed the tanker, you tell me. So why doesn't it crush us? Well, the answer is because we have air inside of us. We, as human beings, developed inside an atmosphere. So we have air all throughout our bodies, all inside our cells. And all air creates pressure. So we have pressure inside of us pushing out at an equal amount as the pressure outside of us pushing in. So there's a balance. In fact, every single thing in this world has that balance one way or another. Whether it's the desk that has air underneath it and on the sides balancing the air on the top, or it's a tree that has air inside of its cells, or a concrete building that has air inside the concrete, inside the rooms, everywhere. So everything on this earth is able to balance that air pressure. And it makes sense because everything in this earth was developed inside of an atmosphere. So it was developed in this air pressure. Okay. Is air pressure always that strong? And if not, how did it get that strong in the video? Well, I will tell you that that video shows everyday normal air pressure. And it's sort of like our dam example. When you saw the floodgates open, you saw the effects of water pressure. When you saw the tanker get crushed, you saw the effects of air pressure. It doesn't mean that it wasn't always there. The dam always has this pressure on it, even though it's really calm. It's the same with the tanker. It always has that air pressure, even though you don't normally get a demonstration. So this is using our thinking concepts, question asking skills. What is different about this tanker? So the air pressure is the same. So what there must be something different about the tanker, because we know that tankers normally don't get crushed. Well, ask yourself. I just explained why things don't normally get crushed, because they've got air pressure either inside them or all around them, balancing the air pressure of the atmosphere. So we know why things don't normally get crushed. What would you have to do if you wanted to crush a tanker, a normal tanker? What would you do to crush it with air pressure? What could you change that would crush it? Well, how about pulling the air out of inside the tanker? So we've got all this air outside the tanker and inside the tanker in a balance. Well, what if you pulled all the air out of the inside of the tanker? We know from the cheeks example that when you pull air out of your cheeks, there's no more air pressure. Your cheeks go from blown up to squeezed in. It's the same with the tanker. Because we reduce the air pressure inside, it doesn't balance all these molecules on the outside, and the tanker gets crushed. You could take anything, well, it have to be sealed like this so the air couldn't get in, and pull the air molecules out of that, and it would get crushed by the air. You can't escape the air pressure in the atmosphere. Okay.